everyone. Today, we'll explore the fascinating world of chemical structures that form the foundation of all living things, from the smallest atoms to complex macromolecules. Let's uncover how chemistry shapes life as we know it. Let's begin with the basics. Atoms. Atoms are the smallest units of matter, made up of protons, neutrons, and electrons. The most common element in living organisms are carbon, hydrogen, oxygen, and nitrogen, often remembered by the acronym CHON, CHON. These elements make up 96% of our body's mass, highlighting their importance in biological systems. Atoms combine to form molecules through chemical bonds. There are three main types of bonds: covalent bonds, where atoms share electrons, creating strong and stable molecules; ionic bonds, where electrons are transferred, creating charged particles called ions; hydrogen bonds, which are weaker but crucial for the structure of DNA and the properties of water. Now let's move on to macromolecules, large molecules essential for life. These are carbohydrates, lipids, proteins, and nucleic acids. Each play a specific role in the body. Carbohydrates, or energy providers. Carbohydrates are made up of simple sugars called monosaccharides, like glucose. They provide energy for cellular functions. When many monosaccharides combine, they form polysaccharides, like starch or glycogen, which are used for energy storage. Next is lipids, or the hydrophobic heroes. Lipids includes fats, oils, and phospholipids. They are nonpolar, meaning they don't mix with water. Lipids are key for energy storage and form structural components of cell membranes, like the phospholipid bilayer. For example, a triglyceride, composed of glycerol and three fatty acids, is a common fat molecule. Third, proteins, the workhorses of the cell. Proteins are made of amino acids linked by peptide bonds. They perform countless functions: enzymes speed up reactions, antibodies protect against disease, and structural proteins like collagen give support. For example, the sequence of amino acids determines like the protein's structures, which directly affects its function. Lastly, the nucleic acids, or the blueprint of life. Nucleic acids like DNA and RNA store and transmit genetic information. DNA is made of nucleotides, each consisting of a sugar, a phosphate group, and a nitrogenous base. The double helix structure of DNA allows it to replicate and pass information to new cells. All these macromolecules participate in chemical reactions to sustain life. For example, glucose is broken down during cellular respiration to produce ATP, the energy currency of cells. These reactions are powered by enzymes, specialized proteins that lower the energy needed for reactions to occur. In summary, the chemical structures of life, from atoms and bonds to macromolecules, form the foundation of all biological processes. Understanding these structures allows us to appreciate the complexity and beauty of life at the molecular level. Thank you for your attention, and Avisala Eshma, mga warka.